So this is going to be about piecewise functions. And so I have like a real life application of piecewise functions up here. So a cell phone company charges $25 for customers using 2 or less gigabytes of data and an additional $10 per gigabyte over 2 gigs. The function below is used to determine the cost, which is C, in dollars for G gigabytes of data used. So that is an example of a piecewise function. So you use a different piece for different parts of the domain. So the next sentence says we're going to find the cost of using 1.5 gigabytes of data and for using 4 gigabytes. So we're basically going to find C of 1.5. So how much do you think the customer has to pay if they use 1.5 gigabytes? $25. So you could answer that question without looking at the function, just by looking at the words. But because 1.5 falls in between 0 and 2, then it's going to be 25. All right, and then we're going to find C of 4. All right, so we also could answer that question using the words in the problem, but if we wanted to use the function, 4 is greater than 2, so we would take that 4 and plug it in for G there. So it looks like this person is going to have to pay $45. All right. So that's a piecewise function. And there are lots of things that use piecewise functions, like packaging, like mailing things, depending on how much weight. This is how much you pay. Cell phone prices, like maybe like dog groomers, depending on how much your dog weighs, you pay more to get your dog groomed. Anyway, there are applications to them. Okay, so let's fill in some notes. Piecewise defined functions have different rules for certain intervals of the domain. So one thing we're going to do today is evaluate piecewise functions. So to evaluate a piecewise function, determine what interval your input belongs to. Right? And that's what we did with figuring out putting the gigabytes in which interval. And then plug into that equation only. So every year I teach this, there'll be people who will like put in a number and they'll get 2 y values. That cannot happen for a function. You're only putting it into one piece. You're not ever going to put it into 2 or 3 pieces, okay? All right, so we have this piecewise function on example 1. It has 3 pieces, and we're going to find f of -1, 0, 2, and 4. So let's just start with f of -1. So the first thing you do is decide which piece we're going to plug it into. So there are 2 of our domains over here that have a -1. But like I just said, we're not putting it into 2 pieces. We're putting it into 1 piece. How do you decide which piece? Right, the one that has or equal to. So if the number is a number over there, you're choosing the one that has or equal to. If there's more than one that has or equal to, someone made a mistake writing the problem, which is possible. But this one, there's no mistake. So we're going to put this into the top piece. And the top piece is 2 times x. So we do 2 times -1, which is going to be -2. So evaluating a piecewise function is just like evaluating any function. You just have one extra step where you decide which piece you're going to use. All right, let's do 0, f of 0. All right, so 0 falls into which domain? we're looking at these over here. The middle. 0 is between -1 and 2, so that means we're going to use the middle piece. And the middle piece, we take our x and we square it. And 0 squared is 0. All right, let's go to 2. All right, so we're back to that same situation we had with -1. There are 2 pieces that have a 2. So we have to make sure we choose the one that has the or equal to. So we plug into the bottom piece, which means we're going to do the square root of 2, which can't really do anything with that. That's just what it is. All right, and then finally, we're going to do f of 4. Which piece are we going to use? The third piece. Because 4 is definitely greater than or equal to 2. So we'll do the square root of 4, which is just 2. All right. You guys may have done this already, like maybe in Algebra 1, but again, it's been a while since you all were in Algebra 1. All right, so the next thing we're going to do, it might be slightly more challenging. We have graphs, and we're going to write the function that was graphed. So looking at example 2a, how many pieces do you think we're going to have? 3 pieces. So we're going to call this f of x equals, then you need to draw a brace. All right, so I am going to start with this piece right here. What does the function equal at that piece? Everywhere on this piece right here, what does the y equal? Y equals 2. So that's what it is going to equal. All right, and then we have to describe the domain that's used there. So we're describing the x's where that piece was graphed. Does that make sense? Okay, so that is going to be when x is between -6 and 6, -6 and 1. And then you do have to decide if you do the or equal to bar or you don't. Are we going to use it for the -6 here? We are. So less than or equal to x. What about for the 1? Yes, less than or equal to 1. So whenever we do this, x is between these two numbers, these are always -1, sorry. When we do it between two numbers, these are always less than. Sometimes they have the or equal to, sometimes they don't, but they are less than. Okay, y'all okay? All right, this is my next piece. What does what does y equal there? -2. All right, and then our x's are between -1 and 2. Bless you. All right, now those signs are both going to be less than, possibly less than or equal to's. What do you guys think for the -1 and the 2? Perfect. All right, y'all try that last piece on your own. Any questions? Okay. Okay, the other one might be slightly more challenging. I don't know. We do need to have a good understanding of what the parent functions look like, and I feel like you guys do. So let's go to write this one. F of x equals, we are going to have 2 pieces. All right, so this first piece What does the function equal on that first piece? 3. All right. And then how would you describe the x's, that domain? Right. Yes, better. Less than or equal to 0. Okay. And then the second piece is part of a parent function. Which one? Quadratic, a parabola. So that's going to be x squared. And then how would you describe the domain on that? Good. So we did an open circle. We don't include it. All right. Any questions? All good? Okay. The last couple of examples, we are going to do the graphs. We haven't graphed a whole lot this year. This might be the first day. I think it is. I know Algebra 2, you do tons of graphs. All right, so here we go. We are going to graph this piecewise function. When x is less than or equal to 1, it is going to be the quadratic parent function or parabola. So let's draw our axes. Now, I have some rulers in that drawer kind of close to Joseph, like between Joseph and Saul. If y'all ever want a ruler, there's some right there. It's up to you. All right, so we are from to the left of 1, where it's going to be a parabola. So if I actually plugged 1 in to x squared, what would I get? We would get 1. So there's going to be a point at 1, 1. Is it going to be open or closed? Closed. All right. Then I'm going to move to the left. What if I plugged in 0? What would it be? It would be 0, 0. What about negative 1? Negative 1 squared is 1. What about 2? Sorry, negative 2. It'd be 4. So all I'm doing is plugging in numbers to the left of 1. And we could do a table if you wanted to. Do y'all want to do a table? Don't want to? Trey doesn't. Okay. I couldn't tell if y'all understood or not while we were doing that. All right. And so this is going to be a partial parabola. So I'm going to try my best to draw this well. There we go. Not terrible. All right. So everywhere to the left of 1 is a partial parabola. Yes, ma'am. Because we are using this for all the x's that are less than 1. So those are the ones to the left. Okay. When we go to do the second piece, we are going to plug 1 in. I know you're not going to want to. But we are going to. So if I put 1 in and I subtract 2 from it, what are we going to get? Negative 1. Is that going to be an open or a closed? That's going to be an open. All right. All right. Now this is a line, right? Y equals x minus 2. What would the slope of that line be? The y-intercept is negative 2. The slope is 1, or 1 over 1. So we can keep plugging numbers in, or we could just do the slope to the right. So that's going to be up 1, right 1, up 1, right 1, up 1, right 1. Now, one thing that, like I said, you're not going to want to do that you need to do is plug one into both of them, but you just do an open circle for one and a closed circle for the other. All right, we're going to do another one. Okay, for B, we have 3 pieces. So I'm going to go ahead and draw my axes. Right. So everywhere less than or equal to -2, the graph is going to be up at 3. All right, so I'm just going to go ahead and label -2 here, label 3 here. That'll help me in a second. So that means I'm going to have a horizontal line at 3. My endpoint is going to be at -2. Is it going to be open or closed? Closed. So I'll do a little close there, and then 3 all the way to the right with the arrow continuing. Okay. And then in between -2 and 1, I'm going to have a line segments. What is going to be my y-intercept of that little line segment? If we were graphing this -x plus 1, good. The y-intercept is going to be 1. So I would just put a little dot on my y-axis at 1. All right, what is the slope going to be? -1. So that means I'm going to go down 1, right 1. Okay, so if I go down 1, right 1, I get a point at 1, 0. Is that going to be solid or open? Solid. Now, my point at -2, like we can continue the slope in that direction also. My point at -2 should be open. So what happens if you do an open circle on top of a solid circle? It's just a solid circle. I know that's kind of weird, but an open on top of a solid is just a solid. So I just connect those points. All right, and then my last piece, everywhere to the right of 1, I'm back up at 3. Is that going to be an open or a closed circle? It can be open. And then I have a segment here. All right. I don't feel super good about this. We'll see how y'all do. We may talk about this again some more tomorrow. All right, so I am going to give you your assignment. I already posted the pages in Classroom.